Everybody. So for today, we are going to focus on the third PowerPoint for the cardiovascular system, continuing to discuss electrical impulses that leads to muscle contraction. So just do a quick review of what was the key component for understanding of the steps involved in muscle contraction. One of the key points that I tried to make was that in cardiac cells, you have no need for impulses from the nervous system. So basically what we're going to rely on for the cardiac muscle contraction, we are going to rely on the cells within the heart itself that can create electrical impulses. The other point that I want to make is anytime I use the word electrical impulse, one of the key concepts that you need to be understanding is this is basically action potential, and that means we're talking about two main steps at least, depolarization and repolarization. Another thing you need to know is that when we talk about depolarization, it's associated with one or both of these ions, sodium and calcium. And when we talk about repolarization, we're talking about potassium. So depolarization can be caused by either sodium or calcium moving into the cell, and repolarization is created by potassium moving out of cell. So this is one of the essential concepts that you guys needed to understand to start with. Basically an overview of the concept. The next thing we're going to talk about is the 3 steps that was important that were basically or required for muscle contraction. That is started with action potential that is created in non-contractile cells. These cells are also known as, do you guys remember, pacemaker cells? This action potential is step 1. This action potential leads to step 2, which is action potential that is created in contractile cells. Contractile cells. And the third step in this process, which is basically the goal of this, is muscle contraction. So these are the 3 steps we're going to be focusing on. So last time, what our goal was to basically review the action potential in non-contractile cells. So the way we describe this, if I go and create the chart for you guys to kind of again review the concept, we created a chart that was like this. We had a threshold that was set at negative 40 millivolt. Another number we learned is negative 60. So we had the initial depolarization that was created by sodium coming in. And when you reach the threshold, that causes the calcium channels to open up, which basically causes the depolarization all the way to 0 millivolt. And this is basically calcium that is coming in. And then you created your repolarization back down by allowing potassium to basically move out of the cell. So anytime, and this is the one I want you guys to really understand, anytime we're looking at ion concentration, sodium and calcium are going to be the 2 ions that are going to be high outside, and potassium is the ion that's going to be high inside. So potassium is always going to leave, except with the exception of sodium potassium pump, and both sodium and calcium are going to come in. These 2 ions are gonna associate with depolarization in some phases or in both. And potassium is always going to cause the repolarization, as you are going to lose positive charge from your cell. Now, understand that what I'm describing here, these are non-contractile cells. Non-contractile cells. So what we're doing here is basically extremely important. Sorry about the motorcycle. This is extremely important. It initiates basically your ability to create the normal heartbeat. So when we're talking about the action potential that is created in your non-contractile cell, that energy eventually leads to creation of electrical impulses within the contractile cells, which is the second part of this process. Action potential within your contractile cells of your cardiac muscle. Now, this process actually has 4 steps compared to the 3 steps we just described. It has the depolarization and repolarization, which is identical. But the difference would be in the stage called the plateau and then resting membrane potential. So let's go ahead and look at some of the details for the contractile cells and their action potential. And then we do a quick comparison between non-contractile cells and contractile cells. So I'm going to actually do a drawing for you on the concept first, and then after we're done that, we can look at the slides themselves. So when we do the electrical impulses or action potential, we have 4 steps. So I'm going to draw them as such. A plateau and then repolarization back to resting. So by just thinking about the number, we have this is about -85. The peak is about +30. And then again, we have the 4 steps. This is your resting potential. Resting potential. This is the depolarization phase. This is the plateau. And this is your repolarization phase. So let's go ahead and take a look at what is happening at each of the steps and what actually corresponds to creating what ion movement creates these components. So depolarization happens by movement of 2 main ions. One is called fast sodium channels, and when they open up, kind of think about the sodium is gonna move in. And you have another set of channels which are considered a slow calcium channel, and when they open, also calcium is going to move in. So the depolarization phase, you can see in, and I'm going to write this is what we're discussing, is action potential of contractile cells. So the depolarization phase of this happens because sodium is rushing in at a very fast speed, and also a little bit of calcium coming in using the slow calcium channels. So this causes a change in the voltage from -85 to +30 millivolt. When you get somewhere up here, which is around +30, your fast sodium channels are going to close up. So up here, we're going to say fast sodium close. So basically, no more sodium is going to come in. But notice that you're still relatively depolarized, right? You're not repolarizing completely. So what creates this plateau phase are the following. Your slow calcium channels are gonna stay open, which means if they're staying open, they're going to allow the calcium to rush in. But think about this. If calcium is continuously coming in, I should be depolarizing because I'm gaining positive charge. But I'm in a plateau phase. which implies that as I am gaining positive charge by calcium coming in, I'm also losing positive charge, so I can basically maintain the voltage. So the only option that I have for ion would be your potassium channels, and these potassium channels are gonna open up, potassium are gonna open up, and it allows the potassium to move out. So you have at the same time calcium coming in and potassium leaving, and this creates the plateau phase because you're gaining and losing positive charge in a relatively similar numbers, so your voltage just stays the same. Now, as you get to here, or during this process, as you can see it, what's going to happen is you're going to start to what? Close up your calcium channels. So slow calcium channels are going to close, which means no more calcium is going to come in, and all of your potassium channels are going to be completely open, which means, potassium is going to continually move out. And moving potassium out of the cell means that you're losing positive charge, so you're going back to the resting potential. So this change that you see right here, going back from around positive 30 to around negative 85, happens because you're closing up your calcium channels and you are opening or keeping your potassium channels open, allowing the potassium to leak out. Now, by the time you're back to around negative 85, your cell is back at resting. One of the key things that you want to change is you want to make sure all of the ions go back to their place, including sodium potassium. So one of the main channels that are going to help you maintain your resting membrane potential would be sodium potassium ATPase, which allows, if you guys recall, allows 3 sodium to move out, and allows 2 potassium to come in. And you also had, again, your leakage channels, sodium and potassium leak channels that are going to help you maintain your resting membrane potential. So the steps that are involved in this, I'm going to repeat it one more time. We have resting membrane potential, significant depolarization that is mainly driven by sodium coming in and a small calcium also coming in. At positive 30, sodium channels are going to close up, but potassium is going to open up, allowing potassium to leave, and calcium channels are going to also stay open. So you're basically having a gain of positive charge and a loss of positive charge, which maintains your potential at about positive 30. As time passes by, you will have your calcium channels completely close up and your potassium are fully open, which causes the repolarization phase back to around negative 85. When you reach about negative 85, then your sodium potassium ATPase and your leakage channels are going to be the main driving force for maintaining your resting potential until a second force comes in and basically create a new action potential. So looking at basically what I just draw for you, we're gonna look at this, and please try, I'm not gonna write anything, but try to practice with me as we go through each of these steps. So what you have on the beginning, this is the first stage. What you have is step one, step one, which is, let me go back. You have a step one in this case, which is, if you guys call it, it would be depolarization. Driving force is sodium in, calcium in. We also have the plateau phase right here, about positive 30. Sorry about the motorcycle. Um, Around this phase, we have your calcium calcium is still coming in, and your potassium is moving out. During this stage, you have just potassium moving out. And during this last stage, which is basically your resting potential, the main driving force would be your sodium potassium ATPase, as well as your leak channels. So that is the main concept I want you guys to understand right now. The four steps that are involved in creating the action potential in the contractile cells. And then we'll continue the concept on our next PowerPoint.